Hello, hello. How's it going? We are going to continue doing Blender things today. Clear my throat there. Yes, hi, Kitty. Kitty wants attention. So last time we made a little coffee cup, I guess you'd say. Um, and I think we might try to do another small model and maybe get into the geometry nodes. The things The geometry nodes are a way to dynamically alter models. Maybe that's the best way to say it. And one of the things that you can alter is the materials. Um, I don't think we're going to do too much with the materials though, but I'm interested in potentially modifying the the dimensions and size of the thing. So like if we had a if we had a box, we could make more easily multiple different size of boxes. We're gonna do hopefully something more interesting than that, but yes, you are just wanting attention right now, aren't you? Say meow. All right. So yes, let's switch over to Blender. That was the other thing that I got working. I've been slowly working on it this week. Finally got the camera angles figured out. I ended up switching from Parcel.js, which is a bundler, to I don't need your tail in my face. From Parcel.js to Vite because we were having so many issues with cache. I don't know if it's related to what we're doing or what the deal is, but it was quite frustrating. um, and it doesn't make for good content either, you know? So I ended up switching to Vite. The bundling is much more. I'm running into much more issues with bundling everything using Vite, and I think it seems like Parcel is smarter about properly pulling the browser packages, and on top of that, dealing with packages that use node-based dependencies and instead using the browser-based ones. Um, Yeah, so that's been another frustration, but it does seem to work faster for what we're doing, and I haven't had any cache issues yet. So I played around with the cameras a bunch, um, and was able to get this working. I still need to hook it up to events and whatnot, and put the other models in there, and probably work on the material because you can see the edges. It would be cool to see like just more definition in that model. So I can basically toggle the scene on and off right now. It's the same number of elements and everything, landing down in the same orientation. You can tell how they fall is slightly different. I'll play it one more time here. But because it's consistently the same models in the same spots, how they fall tends to be pretty similar. Um, so yeah, I think we'll end up the models that we're doing today and in past streams. We will continue to put them into this scene, and we can add like channel pair redemptions. I think that'll be fun. I'm gonna go ahead and stop this server because I got it running locally right now. Because we want to save the resources. Okay. Blender. So I mentioned geometry nodes. Let's actually just pop over to that real quick. Um, I am. Should we just try doing a couple of geometry nodes real quick? So when I'm making my models, I want to make them in a way that once we bring them into a scene through the GLTF to JSX helper utility that the folks working on React 3 Fiber have put out. Within on the React side, you can change materials pretty easily. And if we make our models well, I think we can make the materials pretty dynamic on that side of things. So what I would want to do here, I believe, is going to be making like a model and having different sizes or shapes or something like that. So let's see if we can do a couple of geometry node things quick, just to see if we can modify this box, just so we have an understanding of how the geometry nodes kind of feeds into that part of it. So we'll look through the menus here quick. We got some just general node selection stuff. And they've got a whole handful of nodes that we can add. And then a general node menu, I guess. Okay, so the geometry node ends up being a modifier, and it's attached to a specific element. So we've got geometry, group input, group output. I think so we can do multiple elements and then group them, and then we can, I presume that we can have the geometry nodes interact with the group. So once we're in here, we can do some grouping, volume, vector, math, textures. We talked about textures. And the materials are in here as well. Instances. So we can do new instances. Geometry. So there is a transform. Bounding box, join, raycast, transform, input. Meshes. Okay, so we've got a group input and a group output. I'm not sure what the expectation is here, but I'm presuming that we can add nodes in between this, and input is this whole group, so like the cube group. So within the cube group, there's also the mesh, which I think that's the symbol for mesh, right? Whoop, too many clicking. Spinning. There we go. Okay. So let's, when we drag off, we get another. Okay. It seems like this gives us kind of a filtered list of things that we can do. So like we could set material. And our selection can be, whoop, I don't want the bounding box. I gotta say oh, and there's a material selection too. Is that what that is? just the nodes and the grips and moving around, it feels pretty good. It feels pretty good. I'm impressed. Ah, except I keep doing that. Yes, Kitty, I know you're right here. So what kind of input could we do? Do they have like raycasts separate? I feel like there should be Boolean, some sort of like input boxes. Input. Here we go. I don't know. Hey, Chris. Good to see you. I don't know. Um, I don't know what kind of input would we want for this. So there's the selection node. The socket value has not been computed yet, and material. So let's add a couple materials so we can do an easy switch. That'll be a quick and hopefully obvious way to see the thing that we're affecting actually happen. Okay, so we got one material. Just call it material one. Surface. Let's do a base color of blue. We can duplicate that, I presume. New material. Oh, what? Add a new material. Isn't this a list? I thought this was a list. Oh, here. Yeah, okay, there is. Yep. Okay, so material 2. Material 2 will be green. And I don't want material 3 on linked data block, I guess. All right, so now we got, oh, I didn't actually delete it. I mean, that's fine. Okay, so we got a switch. I want to change material, so true will be this and false will be this. And I'm guessing the output of this will go into that. And geometry needs to go here. So I'm presuming that I click this and it'll switch true and false. So if I click this button, it is modifying the switch. If I take this off, I just have the switch here. I think either would be fine. And you can see it switching in the output. So this is, I don't know what this selection is. What would that selection be for? So is it, do we have to get into, so we have the group. This creates a modifier on the cube group. Um, if hmm, okay, so that's potentially part of it here. Um, wireframe, viewport shading. I think I want the no, I don't want the shading, viewport shading. I think that'll work. Um, yeah, and that includes material. Displays, material, and preview mode. Yep, which is what we want. We don't want to render it because rendering it, I mean, this isn't going to make a big difference because the compute to do that render is not going to be that big of a deal. But in this mode, we're not seeing the material. So we want to flip over to this mode just so we can see the material. And there we go. So the switch shows us the material actually switching. So we have a geometry input through, well, we have a group input with the geometry. We pass that into the set material. We've got a switch that lets us set a true and false based on the switch, and that modifies the material input. Then that output of the geometry goes in the output. So this is the geometry that we are passing into this set of geometry nodes, and this is the outcome of it. So I think we kind of understand how they work together. So what else can we modify? Yeah, geometry nodes seem super cool. For this, I think for what I want to use it, a lot of the nifty things that I've seen tend to be with shaders or materials. I saw a course on one of them by one of the people that worked on them the other day. Nice. There was I suspect I will end up wanting to do this on stream at some point. But let's see if I can pull it up here quick. Yeah. This was a really dope looking implementation. Oh boy, is that an L? It might be an L. I'm looking at my phone if it's not obvious. I'm presuming this is probably shaders or something. That's just so cool. Maybe it's, I mean, I'm sure part of it is structures and buildings and stuff. I've got a background in that, so I think that makes this more cool. But that's just the fact that you can do this is just so neat. Here, I'll drop a link to that in the chat. Stop. Doesn't want to pause now. I literally can't interact with that. All right. Yes, reminds me of Townscaper. Yeah. The as far as the use case of that thing goes, like it's really neat for video games, I think. But it doesn't have enough fidelity to actually do anything in as far as constructing that building. Yeah, kind of like prototyping freeform sort of stuff. You're basically just doing the outside box. It's cool and nifty, but as far as like actual physical use cases for it, not quite there yet. I suspect eventually we will. There are programs that do that kind of thing. Maybe not in that high of fidelity, but it will do some of the structure and interior, at least enough as far as the like architecture prototyping goes. I think that'll become a bigger and bigger thing though over the years, over the next decade or so. Okay, so we did material. I want to see if we can edit the actual like size of it. Point output mesh. So we can extrude, we can scale. So I'm going to get rid of the material. I don't need the material anymore. We want to affect the geometry, I guess. No, scale. Is there a scale? Oh, huh. So we have a few general inputs, and then we have specific things that it seems like it's mostly like selection. So when you drop down, it gives you a list of items for drop downs. So we want to scale. We want to scale the face, sure. And I guess we can do a float. And we'll say true is this, false is this. Oh, I meant to do 0.5. Okay, there we go. That's nifty. So can we do something with that was it under geometry. Can duplicate, separate components, transform. Ah, yes, this is what I am looking for. Let's pipe that in there. Let's pipe this here. You can go away. So, oh, actually, this isn't. Scale, rotation, translation. So, I mean, we can do something like, let's not do a switch. Float curve. Whoa. I don't think that's what we want either. Float to integer, bounding box, Boolean. So that's kind of nifty. A random value, and we can affect the translation. I don't know how to get it to like retrigger. Oh. So this should be affecting the let's not make I presume we want a vector because the vector would allow us to change all three of them. Vector field based on ID index. I don't know what this ID is. Like I'd expect changing the seed would do something. What's position do? Interesting. All right, what else do we have? Geometry proximity. We could do something where the closer you get to it, the further it moves way further. Vector. Okay, I mean, so like we can do something like that. I don't know if is scale really our only option. So we can figure out a better input. Rotate Euler. But I don't know that we just want to separate X, Y, Z. Okay. So we could pull out and then combine X, Y, and Z. Value. So I want a single value. So when we input into scale, we input as a vector. We can both combine and separate. So we can take, are there noise inputs? There's a random noise. White noise texture, noise texture. I don't know if FAC. I mean, we get a value. Float and color. Doesn't seem like the Perlin noise type thing that you've been working on, Chris. Noise, random. I mean, there's the random value. It seems like the random value is the, and we can do, I mean, they've got, yeah, that makes sense. Color and value. And we can affect it in more than, so we can do it in 3 dimensions. So X, Y, Z input vector output some noise value. Interesting. So that's giving us different, and it looks like since we're just exporting as one value, basically like the noise that we're getting is just applied equally to all the same vectors because it's scaling the same. So like if we did something like we want to do a combine XYZ vector, and now we get an input for X, Y, and Z, so we can do maybe something like this. Noise, noise. And if we set all these to be 1 dimension, there. So now we can do noise in separate dimensions, and then it gets combined into 1. Yeah, multi-dimensional noise is referring to the input vector dimension. Here. Let's make that bigger. It's referring to the input vector dimension. The output is a single number. I assume the color output is just the single noise value repeated. Yeah, I don't understand the color versus the value. Maybe it's a different type of value, like a color type as opposed to just strictly the number. Not RGB, noise, 1. Yeah, okay. So I don't know if we can do... Oh, okay. I didn't realize this before, but I think if a line is red, it's not a valid connection. So if I bump this up to 2, we are now putting 2, which is a vector, into x, and that's expecting a single value. So what does W stand for? I guess just white noise, maybe? Yeah, and that would be up to the 4D. Okay. Yeah, that's pretty nifty. So if we did something like is there a random? Can we spin off? We want a random value from min to max. Can we do multiple like this? Yeah. I don't know if it's actually going to be random. Interesting. I don't really get how this random works. It almost does seem like the noise thing is more what I'm expecting to see. Yeah, integer has to force it to be 1. Which is probably... It's odd that it doesn't... Oh, wait. Disconnected. I also don't know the dotted line. If you look at the lines, they start out green and then they turn gray. So that must be like a type conversion or something. So if the range is 0.1 to 1. Yeah. So I think we want float here, and I think this makes sense. Oh. Wait. Oh, yeah, it can be a float. Integer numbers in Perlin noise output to 0, so maybe the same here. So we do want to pass on a float. I don't understand why this isn't working though. And the C doesn't actually seem to affect anything. Okay, so what else can we do? We've got that transform. So we can modify. That's basically everything that's in this context menu here. Are we able to actually scale dimensions or something like that? Or can we attach... So like if we would look at the properties, Like, can we attach to specific dimensions and pass values into specific dimensions? I'm not quite sure where that would show up even. Vertex groups, shape keys. Object constraints. Motion tracking. Oh, that's kind of cool. Okay. What is this? Physics property. Okay. I don't think I might end up dealing with physics at all in Blender, because we will likely do most of that in our React 3 fiber scene. Okay. Here, this was looking. Animate property. So now where does that show up? It shows up as an animation. Motion pass. So it seems like what we can do. Yeah, I think most of that's all within the animation itself. So that would be something like, presume that you rig it and tie it to an animation. So your animation could then affect like the scale of something or the rotation. But that's what I was looking for. I was wondering if there was a dot, this dot thing that would tie it to the Blender nodes. So I think from what I'm seeing here, all of our Blender node stuff is going to be very self-contained. If we want to do anything with the blenders or anything with the nodes, it's going to be in that view. So what else do we have? We have some vector, we have utilities. We could do some math. Textures, text, point. Mesh primitives. So we've got a cube. This seems to be what I'm thinking about. So if we got a group input. I don't know what the second option is in the group input. So we can add, vertices. So if we just ignore the input completely, we can actually have a mesh be output directly into the, oh, okay. Okay. We've got the group. We can do a make group from selected node. Can I do it like that? How does this group thing work? Group input, group output. So we've got an input and then we have an output. I don't know what that socket value is, but can we make a group from selected nodes? No. It might actually be Oh, I don't know how to go back. So this group outputs a vector. Oh, that's kind of handy. Um, okay. So I've now grouped all those things into one thing. So that's a way to LOL, yeah, LOL, LOL, forever grouped. You know, I saw this the other day. If you see WTF written out, your brain tends to actually translate that into the words. If you see LOL written out, you tend to just read it as LOL. And that totally applies to me. So if we group it, then it becomes an option here, and we can flip between the groups. So this is seems like a way to just help us organize it. Wait, which one translates to laughing? I'm not sure. Oh, like if you read it, which one translates your brain to say laughing? I don't know. I guess. I mean, yeah. Haha, I guess. I mean, I think we understand that LOL means laughing out loud. Oh, so WTF, if you see it written when you read it, WTF, you translate it in your brain to actually be the like completely set out. Um, but LOL, when you read it, you translate it in your brain as LOL. You don't like make the actual. You read it verbatim and understand it verbatim, but WTF you actually like translate in your head. Yeah, WTF. Okay, so and we do still now have this node group. Okay, like can we get rid of the node group? Okay, unlinked data block. Just say users. Okay, I don't understand like how these things stick around. Like if I don't want that anymore, how do I just get rid of it? I made a group, and now that group's just like there forever. There's this unlinked thing, which I presuming I understand that as like delete. But how do you tell that it's like if you click unlinked data block, it's still there. I don't I don't I don't understand it. Okay, so group isn't actually group in the sense of like combining multiple meshes. So we have oh, so we can do some other things with the meshes. Shade smooth. Um, I can't really think of how we could use these. Mesh to points, split edges. Join geometry. separate. Okay, so if we've got a geometry here, and we have a mesh here, we can do things to the mesh. Can we combine it, merge by distance? I guess just join. Okay, so that like bigger circle thing. So if I move this, is the other cube there? Layout. Oh, no. Why are we doing keying? Doesn't seem like it's there. And if I just go straight into here, oh, I guess I moved it with it. So I was moving that whole group. I got it. Okay. How far back can I go? There we go. Shift spacebar. That's kind of nifty. Okay. So we can group input and basically dynamically create new meshes. Also, I just nice. So if we can create new meshes, can we do anything with that? I think for the most part it's going to be a modification of them. I don't know that there's I don't know that I can think of a way to use dynamic creation of mesh primitives. Like we can do instancing maybe, like making a lot of them with different values. True. Yeah, I can see that. I guess that would be something like there's the instances. So you can do let's drop this one in here. What does this give us? Points instance. So we get an instance here. We'll get rid of this. I'm presuming no. Points to instance on. Instance realize instance. Scale instances. Rotate. Instances 2 points and instances on points. Okay, so interesting. So if we have a cube that mesh can be fed into instances. Kind of feel like the instance stuff is something that I'm not going to be able to just like guess. I suspect that output points. Distribute points on faces, points to vertices. So instances is expecting an instance. So how do I make a mesh or geometry an instance? Geometry to instance. So now if I do instances and well, that seems well labeled, yeah. It seems like a lot of it is kind of knowing where these things are located, but also once you figure out like which ones you need and where they're located, it's kind of just matching up the names. So like mesh can go into geometry, instance connects to instances. Um, but the multiple value thing is not entirely clear yet to me. So like, how do we go from? So we have some geometry. We converted it into an instance. So does that mean that, like, if we dump all this geometry in here, what do we do with instances? We have points. We can do scales. Volume to mesh. Join. Separate components, separate geometry. Oh. Huh. So we can get different. Based on what you have selected within a geometry, you can get different pieces of it. Output viewer. What else do we have in here? Translate, which we used before. Merge by distance. Join. Duplicate. Ah. Okay. So if we have a mesh and we dump it into geometry, now we have potentially multiple instances. I wonder how we can scale them separate. duplicate index. Okay. So there's the duplicate index. How can we use that? Because we want to edit them separately, and we want to have like the position separate. Scale instances, which is what we've got right now. So we have instances, and it's in so we have a cube. Now we have multiple cubes. We've got geometry, then we can separate it based on the selection. I don't know that separate thing. Index into scale. That's another thing too. There are diamonds, I guess you'd call them, and circles. What's the difference? Like, I presume that that's not going to work, but that does. And I'm presuming that green to blue means we're doing some sort of diamonds are clearly more valuable. Yes. Believable. So based on the color, it's going green to blue. I'm presuming that's that's trying to communicate that that's a data conversion. But we still don't actually have anything visible up here. So does that mean we could do something like this? And the scale is still 0. So we also had this realize instances. Does that mean that we need to do something like this to get it to actually show up? No. Okay, we've got a mesh. Mesh to geometry. Doesn't actually seem to change anything. Or doesn't actually seem to output it. We can do a duplicate based on an input. We can do a selection. What is that selection supposed to be? True. So I guess this geometry is selected or not. So we get the geometry then. If we do like a separate geometry, merge by distance. So now we've got, I don't know what this selection is. Yeah, this duplicate index, I feel like this duplicate elements is when combined with the instances is kind of what we're looking for if we want to do multiple of a thing. So if we want to have multiple cubes. Delete duplicate geometry to instance. Okay. So we have 4, and now we've got instances. Now we can scale instances. Do we need to then take those instances back into join geometry, I guess? I don't know if instances, I mean, it looks like I can go in there, but it doesn't mean it's actually going to work. Yeah. So what do we do with the instances once we have them? Realize. All right, let's do a quick Google. Blender geometry nodes instances. There we go. Thank you, thank you. What do we got? What does Blender tell us? Instances. Geometry can store instances, which can reference more geometry. So that makes sense. An instance is, you can have multiple instances of one geometry. Instances can also store the ID attribute. The main, no, oh, okay. We did see, where did I see that? When we were doing inputs, I guess. There was a place where I saw an ID. Oh. Interesting. Set ID index. Group input. What's it? Oh. Yeah, okay. Set ID grid index. So that's just giving us like an index. Okay. Let's read some more. Since instances can store geometry, geometry can contain instant. Oh boy. Can we make this bigger? UV sphere. I don't know what the UV sphere is, but we've got a group input. Geometry goes into join geometry. So I'm presuming that the first, like you've got one of these things, or maybe that plane, and is joining the geometry, and the geometry is going out. So you can do instances to geometry. Instance on point. So geometry goes into a mesh. Distribute points of faces. Points. Okay. UV sphere must be a primitive. UV sphere. Okay. Distribute points and faces. So we've got a mesh, which is a circle. We can distribute points on there. And the cone is then a mesh being dropped in as an instance. Okay. Let's just kind of spin this up here. And then we can work with it from there. So we have a sphere. Let's add a cone. Is there a faster way to insert? Node context menu. Shift A. Okay. Shift A. We want a cone. We want distribute points on faces. Just whoop. Okay, so if I do Shift A, we then get the. Okay, I want to hit S to search. So distribute points on faces. Got it. Shift A brings up the context menu. The underlined characters in that context menu allow me to just press that key to jump to it. So curve, if I press R, if I press A, it goes to attribute. Oop, actually I was in the next menu. If I hit A, it jumps to attribute. I can use the arrow keys to go in and out. So V goes to vector. So I want to do search because I want that distribute points on faces, and that gives us that. All right. So we have a UV sphere. We want to hook up the cone. No. Okay. On the sphere, we want to hook up the mesh to distribute points on faces. This is going to give us a whole bunch of points. Then from those points, we can do instance on points. Okay. Did it again. Instance on points. Nope. Instance 2 points. Instance on points is different. Instance on points. So our instance is going to come from this cone mesh. Points is going to come from our distribution of the points on the sphere face. Let's get that one out of here. And we are going to join all of that geometry together. I'm going to join both the instances of the cone plus the original circle itself. And now it's also doing an instance on points based on this plane, I'm guessing. So we've got this plane, and it's doing points on that plane. So if we did just this geometry into here. Okay. That's hilarious looking. Okay, rotation is based on the distribution. That makes sense. So rotation comes into here. The cone it's interesting, like the options are much smaller. That it must be just an old screenshot or something. Let's bump these down. There we go. Okay, so we've got this. We can do That's actually pretty nifty. Let's do 0.01. Nope, that's definitely not enough. 0.1 it is. Our density we can adjust though. That'll make us have less of them. Seed is going to change where they are. Okay. So we can do something where, so our seed and our density is going to be determined based on a white noise input we could do. If we include our order input geometry go, group output, must have gotten rid of that. There's our group input. This would let us do, we need another join geometry. Go into that, you go into here, you go into here. So now our cube is the already existing cube in there. I wonder if we scale this, if it's going to scale the whole thing. Yeah, so it's actually scaling that whole group. So with this sphere, we can do something like that. So it's scaling the actual sphere itself rather than the whole group. That's kind of wild looking. So like I think we could do even something where we remove the cube. No, that takes out the whole thing. So if we don't want add fake user, interesting. So we've got a modifier on the cube itself. I mean, I guess the way to just not include it is do something like that. But we can use that as input, and we can do something where we'd like draw a plane, not show the plane, but use the plane as an input. So what they're doing is they have this plane here, and they've got a grouped input there. I don't know that we actually like care about that, I guess. When we export this, I think we want to export. Let's look at our export. GLTF export does guess it doesn't matter that much. Here we'll go to storage. What are our options in the actual export? So we can do selected objects, collections. If we want to do like multiple models to be included in a scene, if we have multiple instances, I'm presuming that it'll show up as like the same collection, and we'd not be able to modify them separately. But I'm not really certain. I kind of like this though. We are going to I think we're actually going to save this. Let's call it spiky circle or spiky sphere. Sure. I guess we can do a new one. Let's do a new one. Go back to geometry nodes. Now we've got this cube. So we can use an initial element as kind of the base. With that base, we can then kind of modify it. Is sort of what it seems like the expectation is. Duplicate elements, point. So we can get points, which is dynamic locations with on a face. What else can we do with that? Let's see what other examples this has. Instance processing. Okay, not much else. Yeah, and see, this is really interesting. You get 3 meshes: the plane, the sphere, and the cone. In our case, it's just the sphere and the cone. So if you'd like, this literally looks like submarine mines. If you would want to do a scene, an underwater scene with a sub and 100 of those, you probably want to instance that, I'm presuming. So if we continue down this idea, what we've got: the sphere, an icosphere, a cylinder, a cone, a plane. I think if we're doing small elements that want to drop, what's a meta ball? Oh, interesting. I definitely want to get into the different types of okay, that's kind of, this definitely piques my interest, the physics stuff. Armature. I'm guessing an armature is how we would do the rigging for animation of elements. We can actually put a text in here. Dumb stare dumb. Oh, it's IFC. I encoded an IFC plugin. So like if we've got a torus as the input, we do a group. Oh, I need a new geometry node. Okay, so we got a group input. We can then take, say, distribute points on faces. A join geometry would then give us the same in output. We could do, what other meshes do we have? Cylinder grid, icosphere, mesh line. Guess we'll do a mesh circle. So that'll give us points. We want to do instances. Instances 2 points. Points goes into points. Our mesh circle goes into instance. Instances go into join geometry. Okay. I don't think mesh circle is what I wanted. No. What other options do we have for our mesh primitives? Cones, cubes, cylinder, grid. It's kind of interesting that geometry to instance. I guess if you take a couple different pieces of geometry, so we've got a torus in here right now. If we do something like a mesh icosphere, we are doing geometry nodes on this. If we put this geometry in this, can I do that? Is it gonna let me? I want to combine these collections. New collection, paste, mark as asset. I thought you can move these meshes within. Okay, so I've got a collection. Oh, okay. Instance selected collections to active scene. Oh, okay. So we have a scene collection, and then we just have a general collection, of which we've got those two pieces of geometry. Can I do a modifier on a collection? So that actually created it on the icosphere. Ico? Whoop. I just deleted it now. I guess we kind of need to have, if I wanted to put a new piece of geometry in here, how do we do that? Add a cone. Cone ends up showing up as a separate, I don't know the name of this, a separate group. So we can shift it between collections. So if I'm in here and I want to do something with that collection, collection info, that's it that I get. I'll put each child of a collection as a separate instance, sorted alphabetically. And we can get the geometry within that collection. So I think we could do something as far as like instancing and whatnot goes with the whole thing. What other primitives do we have? Cube, cone, grid. Okay, so we can do the sphere in here. Let us tone that down a bit. So we can do something like that. But if we wanted to have the radius change, instance index, so we're feeding an instance into here. If we wanted to change the scale of the instance, is that going to change it for everything? So if we did like white noise, oh, there we go. So it is per instance. Hey, look at that. Okay. Now, I guess it's a modifier on that. If we would like bump this up, for instance, yeah. 0.15, I guess. That's kind of cool. We'll bump up the density a little bit, say 15 maybe. And now we basically end up having this. So this isn't per instance. What other white noise is there? Noise. So that's giving like different. Okay, so that is giving a little bit of random on there. And we can change the seeds this way. It definitely seems like we want it to be. Guess I gotta do vector. If we want to keep them all the same, I think white noise is the noise is the thing that we want to do. Whoops. Noise. And well, so that's the vector. Yeah, it feels like this is sort of the thing. It feels like that white noise is sort of the thing that we want to do in this case. So now that we have those instances, we could do something where the oh, so we've got different number of subdivisions. I kind of actually want it on kind of like it on 1, to be honest. And the scale is scaling off of that original value. That's kind of nifty. What else do we got with these instances? It seems like the points are pretty much points on a phase. What else can we do with distribute points on faces? We can. What is an attribute? So we can get a specific thing. Capture, domain size, store named attribute. We can do some curves. So we can do some curves, and then that would let us do extrusions. So we could do what would be a if we do what would be a good thing that we could do with the curves? Mesh primitives. Map range. Oh, okay. So you can map from one range to a different range. Vector, utilities, texture, text point, set point radius. So what else can we do with points? So we can do instances to points, instances on points. We can modify an existing mesh, edge angle, vertex, neighbors. We can scale specific instances. It's a convex hull. Geometry proximity. So from a piece of geometry, you can get a bunch of pieces of information about it. um, yeah, let's try some curve. Oh, star. What is that? So we get points on a star, then we get the curve. From a curve, we can do curve to mesh. What does that look like? Okay. From the mesh, we can do mesh to points. Interesting. Mesh to curve. It's a dual mesh. I don't know what a dual mesh is. But we can extrude the mesh. Um, Interesting. So we don't have a face. Do we want to do, what kind of star would we want to do? I guess we would want to do um, mesh to curve, mesh to points. And if we do another extrusion of that, oh, that's interesting. The top is, but the bottom is not. That's kind of unexpected. Um, so curve to a mesh. If we want to then extrude, we want to fill. Let's do mesh to point. I think I remember seeing a fill. Curve, fill curve. So that ends up giving us a mesh. And now we have an extrusion. Interesting. I wonder how we could fill the bottom. Fill curve. What else do we have in the curves? Curve to point, curve to mesh, fillet. Set curve radius, tilt. Oh, there's a lot of stuff in the curves. And we can kind of do some unique shapes in here too. So if we've got, and like this is cool too, because now we've got like dynamic number of points. Twist. Whoa. So we've got a 6-point star, and it's got a hole in the bottom. We are filling the curve on the top, and then we're extruding it. So if we just go straight to this, that's why an extrusion is just pulling it up. So we're not actually filling the bottom either. Fill curve. Top and side. I'm okay. So that extrudes the edges. So now we can do, oh, so if we just extruded the edges, now can we do a top? We've got a mesh. Is there mesh, flip faces, extrude mesh? There's an inset within meshes. Edge angle. Oh, I was curious. Oh, but there is an edge. No. So how can we get a top on there now? Material index. I don't know what a mesh island is. Face is planar, face area. So that's information about the actual element itself. Mesh Boolean, mesh to curve. So I guess that gives us the fill curve. I don't know what the. Here, let's see if we can pop over to the doc real quick. What are the. So we're in geometry nodes. Oh. What are the different values in here? I feel like, yeah, I think some of these are screenshots are out of date. Node types. Oh, interesting. Standard mesh input selection. So, what does intro say? The geometry. Oh, that's pretty nifty what they did there. Oh, and they've got controls then. That's pretty nifty. So once you have a geometry node, you can then see it in there. Cool. So object properties. Cool. So I guess if you would have an input, it would show up here. We could try that actually. Input. Let's do a value, I guess. So how do we get it to toggle node mute, toggle node preview? Oh, options. So you can hide. Okay, so that's how that other screenshot was doing that. Like, um, we can. No, it's not doing it. Oh, there we go. There we go. That's what it was doing. So that's how the screenshot was slightly different. Inspection. I am curious how we can get it up here though. Invert controls. Global reference. Do I need to select something in here? Output attributes, internal dependencies. They've got the thing selected and then geometry nodes. So within there, take user, assign new geometry node group. Yeah, I don't know how you get that in there. Okay, so we can search. It's fine. Oh. Must be, so a node must be connected to the group output to have the value for inspection. Oh. So how to get rid of that now? Insert keyframe is set to default value. Delete nodes will reconnect nodes as if deletion was muted. I don't. Does it show up here? Group output properties. Oh, you can change the color. Oh, that's kind of cool. Tool, select view, outputs. There we go. Okay, so we can do inputs. Type is a value. Oh, integer. Integer. Um, so does us changing it here, it doesn't actually seem to change that. I suspect it's something like that though, where based on whoa, what was C? Input. Hey, there we go. Okay. So we got geometry, and we can actually have an input that shows up on the side there. And geometry input default, we want it to be an integer, and we want the default to be 6. Min is 4, I guess. Max is 32. This is going to be points. Okay, so now we can change it here. Okay, that's really cool. So that is now actually connected to, that's actually connected to the, what do you call it? That mesh in the collection, I guess. That's, and honestly, that like that's probably the best way to handle those inputs. I like that. And you can tie it to animations. Curious. Okay. So we have this. Let's see if we can get that top back on there. We'll get the top, see if we can get the top on the star, and then what should we do with it? Could we do like a rotated extrusion or something? So we have a curve. We can do mesh boolean, mesh to curve. Oh, okay. So this is combining meshes. Fill, fillet, sample, subdivide, trim. So we can modify it. Primitives. So if we do something like a mesh circle, I suppose, and we've got a curve. Can we? Oh, the mesh circle actually has lines. It's not a pure circle. Curve primitives. Curve circle. Okay. Now, if we take that curve and we do an extrusion, we do an extrusion on the edge. Can we do like a curve, fill curve, curve to points? I'm not sure how we could do, so I mean, this will give us a mesh, which is how we got there. Curve to mesh. Let's do a join. Mesh to geometry, geometry to here. So we have a circle there. But we don't actually want to fill the circle. We want to extrude. I'm not sure how we would do that. Okay. If we've got a mesh, what's a dual mesh do? So we can do two outputs there. I don't know what the dual mesh does. Can we look it up here? Modeling geometry nodes. Node types, I guess. Dual mesh node. A mesh into its dual. Faces are turned into vertices and vertices are turned into faces. Oh. Here's a use case where they're using the noise texture and then applying that to the scale. Huh. So we have an icosphere into a dual mesh. I'm not quite sure how that one is working. All right. So if we've got a star. If we take that curve, can we fill it again? Like, can we do two of these? Fill curve, mesh. Now, can we do a transform? Transform. Mesh goes into geometry. Geometry goes in the join. There we go. And that is being determined by. So we have a fill and we have an extrude. The extrude is based off of the offset, I guess. Points. We're going to do another. We're going to do this offset. We want to change the offset. The offset is a integer, I guess. Okay. So it is a vector, actually. Interesting. Okay. That'll work. So we need to do the vector here. And then we can also tie this to the translation. But we want So then this can give us like 5, 5, 5. So now we got a bottom and a top. And we can do there we go. So now we've got a star which is extruded and has a top and a bottom. Okay, so that's pretty dope. And from there we can also do a twist. So we've got a star. That might be a little bit more difficult than what we have. Offset scale. Okay, so that lets us actually scale the value based on the value coming in. So if we wanted to do kind of like a cone, so it was a bigger star and then went into a smaller star, we could. I'm gonna keep it as like a small piece like this. I mean, dare I do more with that? I kind of want to see some variability in that extrusion. I mean, we could do two extrusions. We can do a positive and a negative. Let's see if we can get it to. What other options do we have as far as like extrusions go? So we do extrude, mesh, split, subdivide, scale. Like if we did a line and then we could do a curve. Can we extrude along a curve? So there's curve primitives, and we have something like a quadratic. Come on, go away. I just want to see this one. So that would give us a curve. Start and middle resolution. Can we extrude along a curve? So if we've got two meshes, top and bottom, rather than doing the extrusion off of the star and going up, can we instead do an extrusion following the points? Ooh. How would we go about that? I think we play around with this idea a little bit. Been going about 2 hours now. Let's play around with this idea a little bit, and then that might be where we call it. So we got the Bezier. We want to do a transform on it, curve into geometry into here. We now have it higher up in the air. 90 degrees. So now if we do We almost want to like rotate around a point. Mesh to points. So we can extrude along faces, edges. We also have a mesh to curve, mesh to points. We can distribute points on faces. This is convex hull again. Geometry convex hull. It honestly kind of feels like convex hull might be something that we can use. Convex mesh that is enclosing all points in the input geometry. So if we have a list of points, here we're actually gonna copy this, paste. We will clear the output and we will clear the yeah, let's leave it there. Dare we? I guess whatever. We can't break it too much. And it's just a funky looking star, so I don't think it'll be that big of a deal. So we are doing a transform and then a fill with an extrusion. We've got this curve. If we do this curve, we've got two curves here, fill curve and fill curve. If we from there get points, curve 2 points, we can say we want a curve to points and a curve to points. The transform, we're going to first transform it. So now it's 1 meter in the air. And whoop. Okay, we've got 2 sets of points that should be in the shape of the star. And from that, if we do this and this, and say, hey, from there we want a convex hull, what is that going to give us? Okay. We have a star with points based on this. What? Okay. So it's not like it's almost like a bounding box. That's kind of wicked. So it's not like a shrink wrap, it's more like a bounding box. So if we've got, whoa. How are we getting count? Curve to points. Okay. Let's evaluate to do. Okay, so that would be like points along. Then we're joining the geometry. I guess the points are like, so the points are distributed along this thing. And then we get, I don't know what's determining. Oh, I don't know what is determining, this like, I guess it's sort of like a diamond shaped thing. I mean, we don't want to keep that, but what we do want to do is say, if we've got a bunch of points, what can we do with these points now? Point. We can do points to a volume. With a volume, we can do a volume to a mesh. So if I give it a bunch of points, come on. All right. What is that? What is that hotkey for? Okay, so I can only give it one set of points. Can I combine points? Points to vertices, distribute points, set point and radius. Oh, set point radius. Okay. So point is like a thing that has a size. So from those we can make a volume. And the volume can become a mesh. Can we combine volumes somehow? Face is planar, face scale elements triangulate. All right. Let's try that. Let's just see what it does. Okay, so we've got points. Oh, it's like a point cloud. Interesting. Interesting. I don't think that's what we want though. If we do points to vertices, that ends up giving us mesh. I don't know that we can specifically get mesh to points, extrude mesh. Like, what if we use the convex hull for this? Volume to mesh, vector, utilities. Join geometry. So if we do another join, I think it's just like a general. If we do something like this, this is gonna give us, yeah, a thing joined. And if we then have a mesh to, or points to mesh, is that what it was? Points to vertices. Okay, so now we got two sets of them. We can do, if we do a convex hull, it's just going to enclose that whole thing. If we have this geometry, we can, how do we combine them? We can extrude. There's really not too much that we can do with the vertices, is there? So if we've got points, so we do points to vertices, there's not too much that we can do with those. Is there something like a bounding box duplicate geometry proximity? I feel like we should be able to somehow do an extrusion along a face. Offset. So if we do extrusion from a vertice, what does that end up looking like? What do we get out of that? So it's extruding it out from a point. Yeah. There's not too much we can do with vertices, is there? Curve length. Subdivide curves. We can join input instances, instance on points, material, flip faces. Yeah, I don't know that we want to play around with points too much like this. Setting the curve to a point isn't seeming to help us here. So if we've got a curve, we want to convert the curve into a mesh. So from the curve, we can do curve to mesh. There we go. Curve to mesh. Profile curve is going to give us that sweep, I think. So we've got a curve. Okay. We've got a curve. We don't want to do curve to points. We want to do a curve to mesh. We're going to ignore the profile curve. Hi, kitty. Come on. We don't need to go on the desk. Fill caps. I mean, I think we do. So I want to do a curve. So I do want the profile curve. Let's put that in there. We want a curve primitive. We want a quadratic. Whoa. That's going to be the profile curve actually. That's going to be that. Oh, not outer points. This curve. So it's sweeping it along to where it ends up being. I don't know what that fill caps is. If it's cyclic, fill the ends of the generated mesh with n gods. We do. I do. Cat scratch my couch. No bueno. All right, so it ends up being a sweep along the star this way, which is honestly kind of nifty. I don't mind it. But that's not what we're looking for. We don't want to sweep from there to the middle. It ends up being cyclical, yes. But we want. I guess I don't mind that. I could copy, I could duplicate that. Let's put another curve in here. Let's see what else we end up getting. So like if we do a curved circle, if we make that instead. Okay, so it is doing it to the middle. Curve spiral. Whoa. And what does that curve just look like by itself? Okay. Curve line is literally just a curve or a line. Quadrilateral or quadrilateral is a square. An arc. So I think we do want the star. Profile will end up giving us it that way. So it is filling it in internally. If I want it to be a sweep around the whole edge. I don't know. I actually I don't mind this. It's not exactly what I was trying to hit, but I think I will end up saving this. So it's doing a profile, and once it kind of gets into the middle, it just like encloses it. So we've got a curve to mesh. So we now have a mesh. If we can duplicate the mesh. So there is a mesh to curve. Okay, star. I get rid of those. I don't want that right now. Star gives me the curve. A extruding a curve will give us a mesh. No. Curve mesh. Curve to mesh. Oh, I need to do edges. That's what I was forgetting. Star, curve. That's how we did it last time, right? We had a star, the curve. Is there a curve to mesh? Curve to points, fill. Did we fill first? Not really what I want. What did we have before? I'm trying to get it to extrude up. Mesh. Extrude mesh, flip faces. Mesh to curve. I mean, I think we want the mesh to curve. This wasn't actually. Whoa, which one was it now? Mesh. All right, I'm getting confused between all of them. Curve to mesh. Curve to mesh gives me this. And then if we do the mesh to curve, curve can then go into this. And then this can go there. Oh boy. I definitely want to play around with this profile curve. But I don't know that we're going to be able to get it to do what I'm expecting. Oh, so now we're back to kind of that thing that we were looking at before. So from that, we want to, I think we want the extrude. We need a mesh. From a curve, we can do a curve to mesh. But there's also the fill. I think that's what we're doing actually. We're doing this, into this, into this, into this. Okay, so that gives us that. So now that we have a mesh, if we say mesh to curve, what is that going to give us as far as our sweep? Something real wicked. If we change this to be something else. Nope. So, I mean, it's kind of in the vein of what we're trying to achieve. But the sweep is just going the wrong direction. So we've got a curve. Like if we did a curve, I think what we're seeing here is we've got I think these are like curved lines. I wish you could see like the parts of it. It would be kind of nice to be able to see the parts of it. We've got a curve. Curve to points, fill, fillet. I'm actually curious what this is going to do. Not much. I do want the sweep. It's just sweeping in the wrong direction. So getting it to do... I think we're going to have a hard time getting it to do what we want here. Trim, curve, subdivide. I mean, we can try cutting it and see what that ends up giving us. Reverse. There is that? I think we're like in the right ballpark. Just getting that sweep to do what we want is going to be difficult. Curve length, fillet. And I don't know that there's anything else that we want to do with the mesh. Scale elements, dual mesh, extrude. Yeah. So to do a sweep how we'd want it, I guess it's kind of starting. All right, if we get rid of the extrude, let's do this. That's giving us a sweep from here to here. If we change these, yeah, so it's actually changing that. Actually, I don't mind that because we can affect this. And we might be able to just get it to... I'm kind of cool with this. So if we take this, can we basically duplicate it and flip it? Utilities. join, merge, curve. I want. Do we make instances out of it? I don't think so. Geometry to instance. I think we could do this. So this will give us 2. And then we can do a transform, geometry, transform. And then we go like this and this. We want to do and 180. Well, that's not at all what I was expecting. So it's actually like duplicating the faces. Wow. This is actually kind of in line of what I was hoping for. I don't quite understand it, but I think this is actually something that we want. So how did we merge these together? Join, we definitely need to join, I think. Whoa. Join geometry. Don't think this is exactly what we want here. Nope. We've got duplicate elements, and we want to feed them in. This part still escapes me a little bit. Having, so if we have multiple instances now, translate. I guess not. Instances, rotate instances. So we are duplicating. All right. I want the mesh to be mesh to point curves, triangulate scale elements. I want to take the geometry and geometry to instance. Okay, here we go. So we got geometry. I want to put it into here, and then I want to join the instances. I want to change them separately though. Geometry instances. Oh, I need a duplicate. So duplicate. So we've got duplicate. So we've got mesh into geometry. Based on the face, we want to duplicate and into. Come on. Number of duplicates to create for each album, or for each element. Duplicate index. Geometry to instances. Do we actually not need that? Hmm. All right, I'm gonna have to figure out how to. I feel like there's got to be an easy way to copy that and flip it. I think we are gonna call it though. We've gone for a few hours now, which is longer than I was expecting to go, but. Let's see. Merge, transform. Yeah, I feel like we want to do something like we want to create instances. We want to do it. Whoop. Um, Man, I feel like we're so close. We're definitely gonna have to play around with this more in the future. Because I think we can do some interesting things as far as kind of programmatically modeling. Flip faces. I want to get those elements. I think we need instances. Instance on points. Instances 2 points. Let's look at the realized instances real quick. Note types. Realize instances. Into real geometry data. This makes it possible to affect each instance individually. Okay. So if I've got more than one instance, so geometry to instance. I don't want to actually convert. I need to duplicate it first. I think I need to duplicate it. Geometry to instance. That's going to give me instances. If I am duplicating the instances, that'll give me 2 instances. If I then do instances and realize instances, now I've got 2 sets of geometry that I can affect separately. And if I do rotate instances, realize data and input geometry is ignored. Okay. Do I have them backwards, perhaps? I go this into this, this into this. I don't know. Oh, okay. So it does say 2 instances. If I go just straight into here, we've got 2 instances. The selection and the pivot point. So I think I do want to do realize. Realize instances, because that'll give me the 2 separate instances. Realize data and input geometry is ignored. I don't think it's actually giving me. So I've got one instance here. Geometry 2 instance. Okay. So I've got one instance there. If I want to copy it, how do I make a second instance? Rotate instances, scale. I think I need to do this. Geometry 2 instances. We want to do empty geometry. One instance. Face. Still one instance. That is just okay. Curve to mesh, instances into geometry. This into here. Kill this one. Now how many instances? Okay, so now I have 2 instances. Now instances, if I do anything with the instances, I'm going to be affecting all of them. So I think that's the point that I need to I have 2 instances and they're on top of each other. So I need to affect each of them differently. And I can put an instance on points. Huh. Well, I think we might end up calling it here. Mesh. So we've got one mesh into one set of geometry, and now we instance it. So we've got an instance, and now we're going to duplicate the instances. Realize instances into real geometry data. So we can affect each instance individually. So if we do realize now, realize instances. It's ignoring realize data and input geometry is ignored. So now if we do geometry, oh, you can separate geometry. Now in geometry, can we then transform? Parts of the geometry that go into the first output. So we have two instances. I mean, I don't really care. I just want one versus the other. Boolean, I guess. Empty. What would be float curve? I don't even know what would go into this selection. Integer or ID maybe. So our selection and our inverted. Ah, I definitely have two instances. Okay. Oh. Okay. And inverted. Oh. Think. Whoop. Join geometry. Join. And our inverted. And this. Hey, okay. That was way more. Way more involved than I expected it to be. Since it's a flip. Oh, there we go. Okay. There we go. With a little bit of a hole in there. I think I'm going to close it off. So if we do start, I mean, that's not really what I was hoping for, but yeah. Yeah. I'm kind of okay with that. And then we can do we'll do a face selection object. Oh, let's go into edit mode. Face select. Oh, can I not select the faces? I can't. Interesting. Okay. So mesh shade smooth. Set shade smooth. And I want to apply that to the whole geometry. Oh, it was already on. Cool. And you can actually see the different segments in there for our quadratic Bezier. So as we increase the resolution, we add extra lines in there effectively. But the fact that we had shade smooth turned on means that that isn't terribly visible unless you really reduce the resolution there. There you go. So we got a star. Let's go back over to the modeling tab. Way more effort on that flipping and doing the instance than I was expecting to do, but we got it. All right. Let's see. Is there anybody? Don't really have anybody on my list to raid. That's okay. We can. I think we can just call it a day there. Flip back over here. Thanks for stopping by, everybody. Have a good weekend. We basically ended up spinning up 3 simple models using the geometry nodes, so we can do the instancing and do more dynamic models using the geometry nodes, which is fun. So I think that's sort of another tool in our toolbox. We can do a combination of modeling and sculpting, but then also throw the geometry nodes in there if we want to do like special effects. Like it seems the distribute points is really nifty, where you could do a model and then pieces of that model do a distribution on that specific piece. The one that keeps popping into my mind is like you can model a troll, and you could use the geometry nodes to make little warts on the troll. It's kind of a wild example, but hey. So yeah, I think another tool in our toolbox. I still do want to get into the sculpting, but I think we'll probably do a little bit more modeling, a little bit more of the geometry nodes over the next couple of streams. We'll get some elements in here. We can do. I don't actually have it on here, but we can do. Oh, I turned it off. Didn't I? Earlier in the stream, I had a server running to show the progress that we had on the rack 3 fibers scene and dropping our models in there. So we'll have to apply some materials, maybe work on the lighting a little bit, and I think we can throw a bunch of these models into channel point redemptions, which should be fun. It'll be cool to play with. Physics, drop some stuff on the screen, and we can see past models that we've done. So thanks for stopping by, everybody. Have a good weekend. We'll keep experimenting with Blender in the future. So next time, bye.